The primitive recursive functions were introduced to prove that some functions always finish. This is still an area of research, and that's maybe why you're interested in. If you can write a function by using the following components, you prove that the function finished. It could be very useful in some case of mathematical research. Let's see how to do this. All the primitive functions can be defined by a base of 3 very simple functions and 2 operations. The functions are the following: the constant functions 0n that take n parameters and return 0. For example, 0,1 of a equals to 0, 0,2 of a and b equals to 0. Then we have the successor function, suc that take 1 parameter and return his successor. For example, suc of 1 equals 2, suc of 2 equals 3. Finally, the last simple function is the projection function. id in takes n parameters and returns the ith argument. For example, id24 of 1, 2, 3, 4 takes 4 parameters and returns the second one, which is 2. We can combine those functions by using 2 operators, the recursions and the compositions. The compositions is the function g that takes m functions h in argument. Each function h takes n parameters. H and J are primitive recursive. For example, if we want to see if a function that returns the successor of the second parameter of 3, we need id23 that returns the second parameter. Suc returns the successor, so suc id23 of x1, x2, x3 equals to x2 plus 1. So the result is given by compositions and 3 parameters. So comp3 of suc and id23. The second operation is a recursion that is defined by 2 functions. The function g that takes all the parameters without the last one for the initial statement, and the function h that takes all the parameters without the last one and the recursive functions a state before. The additions is a great example, but I will explain it in another video. All those definitions can confuse you, but it is very important in order to understand the way to prove that a function is primitive recursive. We need to keep in mind those 5 actions to continue with the examples.